Hello, we are Team Melon. Today we want to talk about space. Here you can see how acid travel works on the desktop. In Unity, we can press the run button and magic happens. We can explore our solar system in motion. Using different functions, user is able to zoom and observe the object from different angles. Then you can push the control panel button in the left corner and enter a particular date in fields given. After pushing OK button, we observe that all planets change their coordinates. It means that on 12th March of 2023, planets will have these coordinates. And then we also have a motion slider. In the right corner, we have Explore button, and we can, using it, read some short information about several planets, like Jupiter in this example. In addition, we can see the inner structure of different planets, like Earth. And then we can observe the function for calculating the rocket's trajectory. This function is fully developed in another portion of the program written on the Python using PyQt workframe, where you can choose different solid motors and rocket types, as well as using global forecasting system to predict weather conditions. So how do we do this? First of all, we calculated planet coordinates. For that, we used Kepler's equation and derived the centric anomaly. And using efficient iterative algorithm, we get this value and using formula of x and y coordinates of planets in any given date. These results were served in SQL database and compared to NASA. So the algorithm contains calculation of ellipse axes A and B, and iteratively m, which is mean anomaly value, is changed by adding to b by t, which is orbital period. The next step of our work was creating a physical model of rocket to fully understand what factors will influence its trajectory. As we know, for calculating rockets' trajectories, we should take into account weather conditions. For that, we used Global Forecast System. It's a database that stores information about atmospheric and geological data. Finally, we create PyQt program that takes different factors as input. And as we know, there are three main forces acting on the rocket. They are drag, gravity, and thrust. So in this list, we have all values that we use for calculations. Firstly, we include ordinary differential equations, total force F, aerodynamic drag force, and rocket's thrust. Using numerical integration and discretization, we receive different graphs that represent flight conditions.
Our project also includes a program describing rocket's flight trajectory. First of all, you have to input type of motor that will be used in the rocket. Then you have to input coordinates of launch site, meaning its longitude and latitude. Then you have to input rocket's mass and then inclination during the launch. By pressing the calculate button, program will give you different graphs. For example, thrust over time, and then graphs describing environmental properties during the launch, like for example wind direction, speed of wind, density of air, and speed of sound, as well as rocket's trajectory in a 3D plane.
Our application also have Android version of the work. Here we can see the start button and the solar system working as on a computer. We can enter any data, any date if you want, and see how planets will change their coordinates. And also we have the same motion slider and speed slider. Similar function exploring separate planets is available on our Android version of our application too. So we can choose different planets and read information about diameter, mass, and the number in a sequence. The most interesting is the Saturn and its rings. Saturn's rings are thought to be places of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. We also have another feature related to the AR technologies. We implemented and created the model of Sun and Mercury, as you can see on the video example. Finally, our application could be useful for rocketry and space flight planning, modeling and efficient storage of data, and study of planetary motion and their influence on the Earth. Thank you for your attention, and as Carlos again said, somewhere something incredible is waiting to be known.